Yeah, thanks for that, Brent, and good morning good morning South Africa, to all the listeners and customers dialing in this morning. I should maybe say, ni hao and guten morgen and all that sort of stuff. I don't know too many, but welcome everyone. Yeah, good morning. This morning, I'm going to talk about the application of modern maintenance practices in optimizing plant asset management, and the goal is to achieve maximum economic life of your plant. Quickly, the issues that we will be discussing, the topics that we're touching on, is what are the primary asset management functions in a plant, the pillars of life cycle costing, and then how to target the cost elements through an integrated maintenance plan with some examples there. And lastly, targeting the production and life elements of the plant through an integrated maintenance plan. Okay, let's start from the very fine beginning. The primary functions, the first one is to look at your inventory. What does the plant consist of? What are the elements that make up the plant? Whether it's a diamond plant or a coal processing plant, that will determine the elements of your plant. The next logical step there is to do a theoretical calculation of your life cycle costing based on design and other service related elements, mostly determined by the OEs. Then the following that, the service element, what do you need to do to upkeep those elements, the primary elements at optimum service levels? And there you have primary and secondary elements that you normally find on the plants. Secondary elements, more the elements servicing the main or the primary functions. And then the last step with that would be to do some financials, do some financial planning, look at the cost elements and the time span at which you need to apply the funding, get to a cost, and try and get that to a cost per hour. And also, if you have the necessary data, a cost per ton situation. Okay, now we're all familiar with the equation of E equals MC squared, derived by our good friend previously, to rule the universe. Now the equation that rules our lives on a process plant is cost per ton. Everyone sits with that every day. You thought you were a good technical guy, studied a good technical course, engineering, and you end up running a financial organization. That's the fact of life. The balancing act is to find the point where those two elements meet to produce the best result for your organization, for your plant, or your business. When these two factors are out of alignment, or when the one is favored at the expense of the other, you can be assured that you're looking at a catastrophic event that's going to happen soon. It's very, very important that these two elements are kept in balance, and we will expand a little bit on how to do that, and also how to stretch that and to get the best possible, and maybe even improve that relationship. Okay, targeting the cost elements. There's a basic element, and that is when you start off, look at what are the major or the critical elements on the plant. It could be something like a crusher, as a good example, and the maintenance as directed by the OE around that crusher would be a very good starting point. Following on from that, you use that window of opportunity whenever it calls for maintenance on that crusher element, for example, is to try and slot in as much as possible some of the secondary and supporting elements into that window of opportunity to reduce the number and the time span of those maintenance events. As life will tell us, you will normally find that there are elements on that plant that don't fit into these windows that are dictated by the primary elements. And then there are opportunities there to optimize by re-engineering some of the components, modify them, substitute them with better products or alternative products to make sure that you reduce a number of unplanned events. Another way of reducing the total amount of the time span of that window is to utilize original equipment supplied or refurbished components that are readily available on standby, and you look at it at a pure changeover or a change-out process instead of a repair process for that window. That is a cheap and a very valuable method of reducing the downtime for that event. If you look at the cost elements, targeting the cost elements through an integrated maintenance plan. What we have here is the focus, obviously, as always, reduce the plant losses and consumables through your scheduled maintenance. Running screen panels past the metallurgical life can cost you a lot of money. It can, if you do it correctly, you can save a lot of cost or reduce the cost input into the plant. We're looking at examples where the reduction in magnetite consumption could be achieved, percentages of 40 to 60% reduction in magnetite consumption through better and focused screen maintenance, water consumption through applying the right types of screen panels and changing them out at the right time. There's a differentiation between mechanical failure mode and metallurgical failure mode, and it's very important that people understand the difference between those two elements. The next cost element is the increased recovery or value through the same principle of looking at the difference between mechanical or metallurgical failure mode. Typically, diamond mines, PGMs, those people would be focused on that part of the equation to maximize the recovery of value of the product. So I just want to go back here. Yeah. Probably the most underestimated element of plant maintenance at this point in time is the decrease or the elimination of unplanned downtime. And here what we are seeing more and more, and it is a very, very important aspect of plant life going forward, we're looking at integrated maintenance systems with the specific use of AI. We'll touch on that a little bit later, but already we are seeing huge benefits coming forward to the customers through the use of AI. The protection of infrastructure and core elements. Again, it is amazing what what one can mine from AI. A lot of data available, as Paul mentioned previously. It's the separation of the good from the bad in terms of that data, and also looking at how it integrates with the other systems on the value stream in the plant, in the process flow. Just to mention one or two examples, the tramp metal in cyclones, if you can catch that at the opportune time, identify it fast enough, act fast enough, there's a huge cost saving in the damage that can be incurred in the plant at this point in time, and that is purely from a maintenance point of view. Another example where AI is used is on near density hang-up, same type of element, whether it's in a cyclone, where simple intervention by the plant and unblock the situation, carry on, and production continues as normal. So by using the artificial intelligence, you are able to sort out process issues and on a much faster basis, protect the infrastructure and the core elements of your plant, reducing the cost of the plant in the long term. When plants are running at revenues of effective revenues of anything between 200 and 400,000 US dollars per hour, it's not very difficult to understand the value of introducing these elements to help manage the process. Okay, now when you look at the maintenance aspect of any production plant, and we're talking about an integrated maintenance plan, here are some of the value add options to consider from your supplier and getting them involved in the maintenance, relying on their expertise. The first one is vendor owned and managed inventory. It's needless to say, some of the mines spend a lot of money and there's a huge capital outlay to keep inventory on site, and in order to try and minimize downtime and where there are long lead times on items. Most of the more mature suppliers nowadays can provide you with that element as part of their service, and there's obviously a huge cost advantage there. The same applies for refurbishment and service exchange programs. You know, the need for customers processing plants to keep inventory on site, reduce the quality of the work is guaranteed, and it makes life a lot easier on the site. Fixed cost per ton maintenance contracts is a very, very powerful tool when you look at value add to your plant. The next element is the accessible, and the emphasis here is on the accessible maintenance history. If you mine that data and you look at and you put it into context, you know, the maintenance history, there's a lot to be learned from that. It can be applied going forward into the future with the cost savings applied to that. Life cycle calculations and optimization. It's on the surface a very simple process, but what it does, it helps you to put the life cycle costing and the cost of separate elements in perspective. You add that to value engineering and you look at what is the cost benefit situation in improving certain elements. It helps you to focus on the right elements going forward. And lastly, any supplier that is worth his salt nowadays will be able to provide you or develop AI systems based on your plant, based on your requirements, in order to maximize uptime and minimize downtime, maximizing your revenue stream for you. An example of how a fixed cost per contract will normally take place. Obviously, there's a period of calibration that is required. Let's say a 12-month period to run the plant, take all your measurements, get all the data, determine the battery limits, and then transfer that and formalize that in a contract to separate the fixed and the variable costs that are applicable on this plant, agree on those, and continue to capture the data, site data, and then to recalibrate for accuracy. So this type of contract is a living document. It changes with change of scope, change of material. It can be recalibrated with new information, and it always returns the best possible cost benefit to the customers. The advantages of a fixed cost per ton contract: firstly, it massively reduces the cost of inventory to the customer. Also, whenever there's continuous improvements taking place, the risk of redundant inventory is reduced or eliminated in a lot of instances. The nice one that our friends from the finance department like, it evens out your cash flow. The spikes in your cash flow disappear, and the cash that oils the machines looks a lot better at the end of the day. There's a transfer of risk through the OE in terms of performance of the plant and the products, which is very valuable. The big cost that is a lot of the times overlooked and is not always visible is a huge reduction in the administration, training, employment cost of personnel, trained personnel. There's the element of continuous improvement, purely because both parties benefit from this continuous improvement. The customer benefits from far better recoveries, cost per ton, and the supplier benefits from better performance on his products, and also benefits there in that particular case because the price per ton is fixed. The next mostly overlooked benefit is the transfer of best practices between sites. Without revealing sources or the secrets of one site to the next, our customer can receive the benefit of best practices without revealing the source, and which would previously, because people and sites are working in isolation, would have been hidden from sight. The customer also has to only manage the service level agreement and not 100 people on site. It all looks very easy, it sounds easy, and when people that are good at it does it, you get this situation where people think it's easy. My advice is stick to the professionals and let them do it for you, and you won't get hung up on the gate like this fellow here, this lady here. Okay, on the surface, the integrated maintenance plan doesn't look as if it will save you on your maintenance budget. However, it will deliver an exponential return on your investment in terms of the economic life, total economic life of your asset. The quality and the volume and the quantity of your asset, of your revenue stream will be positively influenced. And lastly, a tip to anyone in working on a plant is never to link any incentive scheme to a money saving on maintenance alone. It will come back to bite you. Thank you.